Hey everyone, it's David here, and in this video I'm going to do a run through of a talk that Daniel and I did at the recent CrowdStrike Falcon Security Conference in 2025 in Las Vegas. And this talk is called Inside the Browser, Taking Control Through Strategic Configuration and Hardening. And as the name suggests, this is all about browsers, and most specifically browser extensions, but we'll get onto that in a moment. But the first question I have for you all is, why do browsers matter, right? I don't think that this is really a difficult question at all to answer. To me, it's pretty obvious. It's where your data lives, it's where we do a significant amount of our modern business, and it's all within a very, very complex piece of software. And the general security approach that browser manufacturers have taken in order to provide security in the browser is to put a big defensive shell around the outside of this software to keep bad things and that happen inside this environment from breaking out using strategies like sandboxing. Think of it essentially like having another operating system environment inside your actual operating systems, and I think we need to treat it as such. But what we're really focusing on today, browser extensions, is one of the large aspects of this operating environment that can actually introduce a lot of risk. And I really encourage you to consider browser extensions as part of your endpoint security strategy. Browser extensions really provide a great mechanism for attackers to not only collect data from inside the browser, but also provide a mechanism to break out of that shell in some cases. And it's worth mentioning before we get into it that the majority of this talk also applies to IDE extensions as well for applications like Visual Studio. So a lot of the points are the same, so just consider that. And really what I want to have you take away from this talk is a practical approach to basically try and look at what extensions and risk that you have in your environment and provide a number of ways that you can hopefully bring some order to chaos in terms of what browser extensions you have installed. But first, we'll start with the general threat landscape. There are three categories that we see of bad extensions. There are malicious extensions, which are intentionally built to be malicious, and that is their primary purpose, and they're just put on the store and they're just not caught by the store vetting processes. There are hijacked extensions, which are supply chain compromised extensions. So it's something that was actually good, which was turned bad through an update. And there's quite a few examples of this. Koi Security, 3 months ago, released some great research where they found that 18 malicious extensions with an install base of 2.3 million users across Chrome and Edge had a legitimate usage at first, things like color pickers and things like that, and they turn them bad later. So it is quite a prevalent problem. And then there is also user-driven extension risk. So these are just extensions that are actually just written badly. They're not intended to be written badly. They're just poorly coded stuff that can introduce vulnerability risk into the user's environment. It's worth mentioning, however, that even though this threat is here, it's typically not great candidates for specific targeting because of the high visibility and typically user-initiated process of the browser extension itself. For threat actors, it's about moving broad and wide here to see what can opportunistically be obtained. And this is either broad data collection or advert injection in order to drive revenue. It's trying to get information rather than straight up malware. And it's difficult to do because of that sandboxing security model that we talked about earlier. Hijacked extensions are actually really quite lucrative though, because the browser extension stores apply the most scrutiny to browser extensions at the time when you first submit them to the store, and updates later must simply pass common use case tests. There aren't as much scrutiny on those later. And it's a really good way to deliver your code out there because of the seamless and highly reliable auto update mechanisms that these browser extensions need in order for the marketplace to work really, really well. But before we get into how to see what's out there and control them, I want to talk a little bit about how browser extensions work. Modern browser extensions are basically contained in a format which is called the Web Extensions format, and this is a collection of HTML, JavaScript, and other assets. There's a manifest file also in here as well, and they're all put together into one single zip file. This is then uploaded to the browser extension marketplaces, and if they are approved, the browser extensions are signed with a dedicated certificate for that extension. However, it's worth noting that on Safari on Mac, extensions are actually compiled applications, not in the web extension format, and they can actually be controlled with something like traditional application control. It's how Internet Explorer extensions used to be built as well. But you know, the bar really isn't that high to build some of this code and get it out there on marketplaces. But there is a manifest, which I touched on just before, where every extension has a file which contains all the information about what assets are in the extension, and it contains a unique extension ID which uniquely identifies that particular extension. It never changes for the life that the extension exists. And in this format, the manifest contains the permissions required for the extension, the URL allow list, and an inventory of all the scripts and assets that are in it. And the signature of web extensions is validated when the web extensions are installed or updated. So the only way to bypass any of this signature stuff is by using browser development mode, and we'll talk a little bit about that in a moment. There is a permission model for browser extensions, and there are a lot of permissions out there. There are 97 at the time of writing, and by default, it's up to the interactive user to actually accept or reject those permissions in their entirety at the time of installation. So it's not like on Apple or Android phones where you install an app and you can sort of give permissions at the time that the actual application is requesting it or take them away later. You know, these permissions are there to accept in their entirety or don't install the extension. And then once you actually install it, the access is not really ever prompted in the forefront again or reviewed. And it doesn't happen that often, but it's just being aware that if the extension makes an API call to a capability that isn't available, the extension will just simply fail to operate and stop working. There is a mechanism on Chrome Edge that was introduced recently which allows you to revoke certain permissions, and we'll talk about that in a moment. So there's a table on this page which shows that a number of different permissions, and different permissions are associated with different risks. The permissions up in the top red are ones that we think are higher risk permissions. There is native messaging, which is probably one of the highest risk ones, and think of native messaging as similar to link handlers. Basically, it's a pipe to an application that's actually outside of the browser that allows you to send data through it. So a link handler is when you have a shortcut for an application, you run that shortcut and it opens, it's associated with a specific app. Native messaging allows you to send data through a pipe to an associated external app. So think Zoom, for example, you know, sending data into the Zoom plugin. And this is really the permission that you need in order to perform like a sandbox escape, because it just provides that pipe to the outside world, but the association needs to be there. There is also file system read and write, pretty straightforward. There's desktop capture, allowing you to take screenshots, things like that, launching downloaded files, and many, many more. You can restrict or scope site access for extensions, but it's really difficult, well, it's not really difficult, it's just probably not worth your time, but we'll talk about a lot of other things that you can do in a moment. So we've sort of covered this part, common attacks, in terms of the type of risks that browser extensions provide. Obviously, attackers will take advantage of things like extension squatting, which is that the real plugin that's here? You know, is that by Zoom, the actual Zoom, or is it a fake one? You know, they'll publish extensions that have similar names, and also, you know, supply chain attack. You know, you've got a good extension, it turns bad later, and obviously the bad one that we've talked a little bit about before. But where do we begin to get an understanding about what browser extensions we have out there and what risks we have out there inside our organization? And the first thing to do is to get visibility as to what's actually installed. There's a number of different ways that we can do this that we'll touch on during this talk. So there's CrowdStrike using the exposure management module. I'll talk about that in a second. Airlock Digital, so we have browser extension control where we can show you what extensions you have installed and control them. And then there are a number of managed capabilities such as Chrome Enterprise Enrollment and also group policy as well. But these are the main three ways that we see are practical to actually bring some order to chaos here. So many of you today will have CrowdStrike exposure management, and the great thing is it's already taking inventory of all of your browser extensions out there. So if you have it, it's worth going and having a look as to what I have installed. And one of the really cool things about this is you can review risk based on the permissions that the extensions actually request. And you can really quantify if you have an issue or not. It looks like this. As you can see in that list, there are some unsavory extensions there. There's like Happy Dog, which is a virtual pet, and many other things that we probably don't want in the enterprise. And one of the funny things about browser extensions is, if you look at this list, is compared to files, it's actually really easy to determine which ones you should have installed or not. It's sort of like clear legitimate business purpose or just not. So it's actually really easy to go through this list and sort of at least take stock of how many extensions you have which you shouldn't have installed. But I guess the problem with the CrowdStrike exposure management module, I wouldn't say a problem, just a limitation, is that you can't actually control the extensions. You can just see what you have. However, as G.I. Joe says, knowing is half the battle, right? But that brings me on to group policy and Intune controls. And the way that group policy allows you to get control of browser extensions is through using the ADMX extensions. It's ubiquitous in the Windows ecosystem. You can download that, and when the browser starts, it will check to see if there's any group policy enforced controls for the browser and respect those if they do exist. There's a ton of customization available through these ADMX templates for the various browser, but not a lot of them move the needle when it comes to actual impactful security. Most of the configurations really are about locking in particular functionality, preventing the user from changing them, and customizing the browser to suit the needs of the organization. But group policy is a contrast with CrowdStrike, because you can block with group policy and allow specific browser extensions, but you can't enumerate what you actually already have installed. So it's kind of like the perfect pairing for CrowdStrike exposure management in that regard. And if you've got both, you sort of have both sides of what you need in order to get a handle on managing the extension ecosystem. There is one thing in group policy that I do recommend you configure, and that is disabling developer mode. I mentioned at the start of the talk that you can sideload extensions bypassing all the normal signature validation by using developer mode, and by disabling it in group policy, it just takes that entire local sort of attack vector off the table. And unless you're an organization that's actually developing browser extensions, no one's really going to be impacted by you turning that setting off. So one of the main things that I wanted to cover in this talk is how you actually go about controlling extensions with GPO. And I really think that this is one of the best things you can do security-wise when it comes to the browser. So there are a number of settings here. The first setting is configure extension allow list and configure extension installation block list. This is really straightforward. It's a group policy setting that allows you to place IDs on either the allow or block list and allow or block them. The block list does support a wildcard, which needs to be put in place on that block list in order for you to implement a deny by default approach when it comes to browser extensions. The real pain here is getting those browser extension unique IDs and managing that, but as previously mentioned, if you have CrowdStrike exposure management, it kind of does this for you, right? But there is a catch to watch out for, which is that the extension IDs are different for the same extension between Edge and Chrome Marketplace, because it's based on those signers and you need different signers per that marketplace. So that's something to just be aware of and don't get caught out by, especially if you have both inside your organization. GPO supports a custom block message if an extension is blocked by policy within your organization, and that's configured in extension management settings. So you could tell the user like, hey, this isn't allowed by our company security policy. And extension management settings is basically a JSON manifest that allows you to declare API permissions in the manifest and a whole ton of other things. So you can declare a rule that applies to all your extensions. You can create a list of explicitly blocked permissions from using certain APIs, and you can target these rules per extension ID if you want a level of strong granularity. And you can also manage the installation state of extensions using the installation mode parameter. There's 5 different parameters. There's allowed, which is the default for extensions. There's blocked, which is users can't install the particular extension. There's force installed, which is you automatically install the extension without user interaction, and you must specify the installation URL for it. There's normal installed, which is you automatically install the installation without user interaction, but users can actually turn the extension off. Then there's removed, which is users can't install the extension, and if users had it previously, then the browsers will actually remove it. So there is something that we talked about at the start, which was called Chrome browser cloud management, or touched on at the start, I should say, that basically leverages this group policy setting. It's just a front end for creating this group policy. It works with Chrome, doesn't work with Edge, and also you don't need to sign in with a Google account in Chrome to use this, but you need to enroll the browser into Chrome browser cloud management. So you set a registry key on your machine which contains a token that Chrome will actually use to go communicate with the cloud service for this, right? And it'll become managed. And yeah, as I said, it doesn't require Google accounts. So if you don't like building basically the JSON manifest that's in extension management settings, you can use the Google front end for it. But the manifest is the same for Chrome and Edge. It's just that Google doesn't want to manage Edge for understandable reasons. But this is the user experience when the extension is actually blocked. You see some extensions are not allowed, and you get a custom block notification there. So how do we control browser extensions at Airlock? So Airlock can either report or prevent browser extensions from being installed. We control browser extensions on Mac natively because they're normal applications. But what you'll actually see inside the Airlock product is a list of browser extensions that you have, and then you can either put those extensions on an allow list, and we automatically enforce a deny by default policy. We also have exception management workflows so that if you need to allow someone to install an extension temporarily, we can permit that as well. And we're also adding in shortly the removal of unapproved extensions that were already there, right? But it's also worth mentioning that Airlock also, because we're performing application control, allows you to control untrusted browsers. So many people will have, let's say, a corporate policy to use Edge, for example. But there may be some users with other browsers like Brave or Firefox inside the organization that, obviously all your extension management work won't actually apply to. But using something like app control, you can actually prevent people from running untrusted browsers. So there are a number of mechanisms there that we've talked about to control browser extensions, but how can you actually evaluate them? What is safe when it comes to extensions, and how do I know whether to allow something or not? As I mentioned before, it should be pretty obvious what's actually work-related or not, but if you need additional assistance, go have a look at some of these resources. There's CrowdStrike, as mentioned. If you're lucky enough to have it, it sort of provides a risk scoring there. There's a site called Risk Breakdown from CR Excavator, and it will actually allow you to put in the URL or the ID of a specific extension, and it will give you a breakdown of that. Then there's also a service called Koidex from a company called Koi, that they provide a browser extension style version of Think VirusTotal, but for browser extensions that you may be on the fence about. There's also a document from Google called Managing Extensions in the Enterprise, which has this interesting sample decision workflow approval that's actually in the document. It's worth checking out. I personally think it's a little too complicated, but it's a good resource just to think about how to manage this across the organization from a business flow perspective. So beyond just extensions, is there anything else we can do to make our browsers more secure? As I mentioned, there are tons of options available in GPO. There are hundreds of them. However, there's only a few that actually really move the needle when it comes to security, because browsers are pretty hardened by default. Some quick wins are disabling telemetry and studies. So you're disabling the data leakage from inside your organization. Disabling your browser configuration, so stopping users from actually going in and turning on and making the browsers less secure from an already hardened point of view. There's enforcing an approved search engine and home page. So this is stopping the malicious hijacking of search. So we've all been there in the past where we've run something on our computer that we shouldn't, and it's changed the whole home page and just creates a bit of a nightmare. This will actually stop that malicious hijack and stop all your search queries going to something else. And also, as previously mentioned, disabling developer mode, so it will stop some of those security features from actually being turned off. But overall, if you aren't controlling browser extensions in your environment, I would start here. First of all, understand what browser extensions you have. Take an inventory using CrowdStrike Exposure Management or Airlock Digital as to what's in your organization. There's review and improve the extensions, so assess what you have and create an approved allow list of which ones you want to allow going forward. Establish an approval workflow, so define a process for reviewing and approving new extensions. So if someone in the future, once you've got the actual deny by default policy in place, calls up the service desk and goes, hey, I really need this extension, how do they actually go about getting that approved? And also then once you've defined that, then enforce your policy and only allow approved extensions inside your environment. Thank you so much. I hope you had some useful takeaways from that talk, and yeah, come visit us at the booth. Cheers.